So in 7.3, we're going to move on from some basic properties of radicals like we did in 7.1 and 7.2, and then we're going to start doing some operations of radicals, and we're going to learn how to simplify radicals and then kind of apply what you've learned using a formula. So the first thing you're going to learn is product and quotient. So we're going to start with using the product rule for radicals. And all that is that if it's the same index, so if you're taking a square root of a number and you're multiplying it by another square root of a number, you can do it. If you're taking a cubed root of a number times a cubed root of a number, you can multiply. So if I have the square root of 15 times the square root of 13, since these are both square roots, I can do 5 times 13 and get the square root of 65. Same thing here, these are both square roots, so I can write it underneath the square root sign and then multiply the radicands. So you get 7xy. Since these ones are both cubed roots, you can multiply the radicands together. You'd end up with the cube root of 2 times 7 and get the cubed root of 14. So if you want to try these next three, nothing tricky. Well, there's one that has a trick in it, but nothing different is going to happen, but it's just sort of good practice. So since these are both fifth roots, you can do the fifth root of 9 times 8 is 72, x times x is x squared, y squared times y squared is y to the exponent 4. Same thing here, these are both sixth roots. You've got 8 times 2 is 16, and then r squared times r cubed is r to the 5th. And then lastly, this is just the one to trick you. So this one's a square root times a cubed root, so you cannot multiply them together, cannot multiply as they have different indexes, different index values. All right, moving on. Next thing we're going to do is quotient, so we're just going to divide, and all that is that if you have a radical with a fraction inside, you can split it up into a division of two separate radicals as long as they have the same index, or if you have an index divided by the same index, you can change it into a big fraction. So for example, if I wanted to simplify the square root of 100 over 81, I can write this as the square root of 100 over the square root of 81, and we were kind of doing this in one of the earlier lessons anyway, but you get 10 over 9. So same thing here, you could rewrite this as square root of 11 over square root of 25. So even though the square root of 11 we would never write because it's not a perfect square, so we would keep it as square root of 11, we can take the square root of 25 and get 5. So same thing here, we can write this as the cubed root of 18 over the cubed root of 125. And then again, you can take the cubed root of 18, but you end up with an irrational number, so we leave it in an exact form. And then the cubed root of 125 is 5. So here's a couple more. This is sort of just reminding you how to deal with variables with exponents. So again, first step, I'm going to split it up. So this is the square root of y to the 8 over the square root of 16. So the square root of 16 is easy, that's 4. How do you take the square root of y to the 8? Well, if you remember from the last lesson, you can write the index as the denominator of a rational exponent. So I could write this as y to the 8 over 2, which means that the square root of y to the 8 is y to the 4. Or you could ask yourself, what do you multiply by itself to get y to the 8? And the answer would be y to the 4. And then you got this guy, that negative stays out front. We're going to do the cubed root of x squared over the cubed root of r to the 12. That doesn't look like a 12, does it? 12. Okay, and if I look at the top, since the 2 isn't divisible by the 3, I'm going to just leave it as the cubed root of x squared. And on the bottom, I've got r to the 12 divided by 3, so I've got r to the exponent 4. So go and practice a few of these, and we'll come back and do the next video.